Hello, my name is Mark Cieri. I'm the Director of Business Development and Marketing, and we're here at Enpirion headquarters in New Jersey. I'm with my colleague.
Hi, my name is Ahmed Abou-Alfotouh. I'm the manager of the System Architecture Group.
We're here today to talk about a latest product announcement, the EN5339, which is an excellent new product, a 3-amp product in a 4x6 by 1 millimeter package targeted towards SSD as well as embedded in industrial applications. I want to quickly talk to you about this product and the space that we're in, specifically in SSD markets. It's a fast evolving, rapidly growing market. There are numerous design form factors, whether it be PCI Express, 2.5-inch SATA drives, mSATA, USB 3.0. Similarly, we could talk about numerous form factors in computer embedded modules, but specifically in this space, high density requirements, whether shrinking form factors or in a given form factor like PCI Express, fitting more storage capacity into a given form factor is very critical. The teams that are working on them, normally teams that are smaller teams, smaller hardware teams, sometimes even lacking power expertise, are faced with this diverse kind of variety of form factors, but also they're usually driving multiple controllers as well. So this leads itself to numerous projects as well as fast time to market requirements. The second thing is reliability. Reliability is critical. Mission critical data for enterprise applications or even consumer applications where you're storing, say, 50 years of digitized photos. You don't want to lose those kinds of data. So availability and reliability are critical. So when you bring these together, including conversion efficiency and cost, this creates the perfect storm that requires a DC-DC power SoC such as our Enpirion portfolio. The 5339, which is in addition to our existing portfolio, enables specific benefits in this space. From a standpoint of high density, we reduce at least 75% the size of the solution footprint compared to discrete alternatives, discrete DC-DC regulator alternatives. In addition, our profile was reduced from our own 1.85 at 3-amp to 1.1 millimeter high, which is a 40% reduction in size. This is important for slimline drives or even bottom sight mounting on printed circuit boards, for example, PCI Express applications. All of this is to increase storage capacity. So this is a key aspect in enabling these customer base. Next key feature, as I mentioned, was reliability and availability. Our solutions are 8 to 10x more reliable than a discrete integrated FET and regulator solution. Thirdly, if we talked about total solution cost with increased frequencies that we run at, which Ahmed will talk about, it lends itself to smaller values and fewer components. And with that integrated inductor, we actually have a smaller BOM. Our noise performance at 6 millivolts peak to peak does not require input and output filtering. And lastly, the thermal performance, like all our high efficiency products, no thermal or load derating. So we don't require oversizing nor heat sinks or any kind of airflow on these devices. The same device, 95% peak efficiency. And again, at these level of reliability, at this level of efficiency, and lastly, because it's a full system on a chip, and he's engineered the full system, the components, the inductor selection, the capacitors, we've taken the customers through that design flow so they have about 40 to 60 fewer design steps and about 1/3 the exposure to design iteration and optimization required. So truly, it's a much more seamless design flow with nearly 100% success rate on first design. So this is important, as we talked earlier, about getting fast time to market with a diverse set of products. I'm going to now hand it over to Ahmed to talk about those key enablers.
Yeah, thank you, Mark. Now, I'm going to talk about the key enabler to come with the market with this very, very small product. And I'm going to show you to what I call it Enpirion pyramid. As Enpirion pyramid shows the three main parts, the packaging, the IC, and the magnetic, and sitting over the system engineering. You see, we here in Enpirion, we optimize the whole components. We are not compromising the same as engineers who are designing discrete. You see, we're optimizing the package design. We're optimizing the IC design, power fits, and the controller. We optimize the magnetic design from inductor. We optimize also the external components. What's allowing this to us that we are doing a lot of modeling and a lot of analysis, a lot of engineering analysis to come with a very optimum solution. In the IC technology, people don't want to go to high switching frequency because of the switching losses. But we came with a new technology that allowing us to go to high switching frequency with optimum solution, with optimum losses. This allowed us to come with a very small inductor, but also we optimize the solution with the geometry, with the material, to lower the switching losses, to lower the losses related to the inductor. In the packaging, we do a lot of modeling to come with a very small parasitics to small losses in the package. We also optimize everything related to the package. I'm going to go to this picture now to show inside the package, to show how small the package is, and everything is small to each other to minimize the parasitic in the package. You see the wire bond. Also, we optimize the design on the wire bond also to make this losses related to the wire bond very small. So we're optimizing the whole solution to make the losses very, very small to come with the high efficiency solution. Not only, but also the high efficiency solution, but also low noise. If you look to the radius where the high frequency current is rotating very small, and if you know the radiated noise is related to the radius to the power 8, you see this radius is very small, make the noise also very small, make the solutions very quiet. We put high frequency capacitor close to the chip, also to make the high frequency current rotating in this high frequency capacitor, also to help make a solution very quiet. So you see, we optimize the package design, we optimize the IC design, we optimize the magnetic design to come with a high frequency solution, a high frequency solution with high efficiency solution, and also low noise solution. Over that, to come with a whole solution with the external component also very small, we do the system analysis. You see, with the inductor selection, capacitor selection, stability, the time domain simulation, we run more than 22 parameters to come with a solution that is stable under all the conditions with all parameters to make sure the part will run under any condition very, very, very stable. Also, this allows us to pick the passive component, the external input and output capacitor, very small, to come with a very small footprint solution. So you see, in Enpirion we optimize, we don't compromise the whole thing to come with a high efficient solution, low noise, with a very small external component. And now when I deliver this solution to a customer, he doesn't need to run any simulation. He doesn't run to any simulation tool. He doesn't run under any tools. Already I selected the component to him. I did the analysis to him. What he needs to know, he just looked at the data sheet, he looked at the selected component part numbers, and just purchase these components, and that's it. Design the part. The Gerber file available online. You just follow the Gerber file, and Enpirion parts already designed in his system. And that's how easy it is designing Enpirion products.
Thanks, Ahmed. So for the 5339, again, this is a 5-volt input device. It's reducing the solution footprint at 3 amps for Enpirion, who had market-leading solution density before, by about 20 to 25% solution density. The profile height is a 40% reduction. Mean time between failure, 21,800 years or greater, which is about an 8 to 10x improvement in reliability, critical for this application. In terms of noise performance, again, 6 millivolts peak to peak, again, no secondary filtering. And then total solution cost, again, fewer BOM, fewer components, higher assembly yield. And again, with this high level of density, this is really an excellent solution. As again, 20 design wins pre-production, pre-release we already have on this device, which adds to our base of SSD design wins. We're doing equally well in this space with computer on module, which again, you have form factors like PC104, Q7, Ultra-Com Express. These are high density computer modules with many of the same features. So thank you for your time.